and we're going to assault it with a variety of threats.
Now what you're starting to see is bullets that are being destroyed. You stopped all those rounds.
Hi, this is John LaPlume. I'm the Vice President of Product Line Development and Strategy for FirstSpear. Previously, you saw us testing our Level 2 insert inside our NOC carrier. We had some pretty impressive results. We're going to step up the protection level now to our tactical insert, Level 3A as specified by the NIJ. This incorporates the threat for U.S. domestic law enforcement of the .44 Magnum, as well as some other special threats. It also meets or exceeds all the threats you previously saw in our Level 2. The carrier that I'm going to put it in today is what we call our courtroom carrier. It's designed for lightweight, every duty wear. Now we're just going to weigh this so that you can get an idea of what the weight of this system is prior to it going and being shot. We're going to try our Apex threat. That's .44 Magnum, 240 grain, semi-jacketed hollow point at contact. There's damage to the back of the carrier fabric, but there's no penetration of the vest at contact distance with the .44 Magnum. We're going to attempt multiple strikes on this panel. We're going to try the same caliber, same projectile, 240 grain, semi-jacketed hollow point. No penetrations of multiple strikes of .44 Magnum. It resisted all of that, so we're going to move into a special threats phase. We're going to fire multiple continuous shots of 9mm, 124 grain NATO full metal jacket. For this, we'll use a special threat weapon, fully automatic fire from a Broger and Tomei submachine gun. There's no complete penetrations of the system from a 30-round magazine at close quarters on full auto. As you've seen, the package has resisted multiple impacts very, very well. Now we're going to try multiple impacts in extremely close proximity to each other to see if we can induce a failure of the system. Those rounds were stacked on top of the .44 contact shot. Pretty impressive results. So this time we're going to induce a failure with a little bit more effort. As you can see, this time we clearly had a penetration. It only took 30 rounds of 9mm fired within an inch of itself to actually penetrate the vest.
So we just shot the NIJ Level 3A vest. Let's check the weight. 3.2 pounds, significantly heavier than when we started. The first thing to note is the carrier itself, because of the energy transfer, as the impact occurs on the strike face, the bullet is stopped, but that energy passes on through and causes rips into the nylon itself. But with the exception of the multi-shot in one hole, we ended up with stops, and that's what we'll demonstrate now. Some of the rounds, as they impact the strike face of this vest, simply mushroomed out and fell to the front of the vest and have been caught into the ripstop that the ballistics were entombed into. The first portion of in the design of this vest is a unidirectional non-woven. That's then going to be followed by a woven aramid that's been quilt stitched, and then there's a third package layer of non-woven ultra-high molecular weight polyethylene that's been quilt stitched into the woven aramid, followed by single layers of unidirectional. And these hybrid packages, the combinations of different monolithic materials, ultimately help in absorption of energy and stopping the rounds. And a lot of times where you'll find the rounds are going to be between these interfaces. So the first thing that was shot at this was .44 Magnum, and if you look at the .44 Magnum rounds that have already fallen out of this vest, you'll notice that they've started to mushroom. So if we start with the beginning or the strike face of this panel, we come to the first round, which is probably a 44 Magnum that's mushroomed out. And we start finding some 9mm that are flattened. And now we're starting to create, we're coming up on that interface that I was talking about. And as we get closer to the interface, you'll start seeing some rounds that have again been stopped. And now at this interface area, you find multiple rounds as well. And then behind that, what we're now starting to see is we're starting to see the result of the fully automatic, where the rounds were being put inside of one another, and when they're placed inside of one another, they start turning sideways, they deform. The copper jacket will now start to become a cutting edge and start driving into these materials, and thus you get the deeper penetration in the two areas where there were multiple shots in the same hole. And as I get further back into this panel, there's only going to be one area of full penetration, and that's going to be that final series of rounds that resulted in the penetration. Other than that, you have damage to the fibers, but now you're resulting in no penetrations anywhere but that last area that we demonstrated.